Hello, this is the lecture number 15 for the chapter integration, and we are starting with exercise 7.7, which is based on the special integral of these three types, which is integration of under root x square minus a square, integration of under root x square plus a square, and integration of under root a square minus x square. This we have already discussed in the special integral, which is equal to x by 2 in all the three, multiply by this x square minus a square into x square plus a square under root a square minus x square and a square upon 2 in all three, and we have minus sign in this and plus in this. With this we have log x plus under root x square minus a square. In this we have log x plus under root x square plus a square, and in this we have, and this three formulas we have already discussed in the special integral. So this will be formula used in this exercise 7.7. Now in 7.7 it is based on the special integral. It is integration of under root 2 square minus x square, which is a special integral of under root a square minus x square, which is x by 2 under root a square minus x square plus a square upon 2 sine inverse x upon a. A is 2 here. Again we have under root a square minus x square, but always you have to make the coefficient of x square as 1. So you take 4 common from the square root, so it will be 2 outside the square root. It will be 1 upon 4, which is a whole square of 1 upon 2. So it is under root a square minus x square special integral, which is x by 2 under root a square minus x square plus a square upon 2 sine inverse x upon a, where a is half. Arrange this, it will be 1 minus 4 x square upon 4, and after taking it outside the square root it will be 2, and similarly is 1 upon 4 into 2, that is 1 upon 4. You can take half x by 2 common in this. Now it is a under root x square plus 4x plus 6 with respect to x, and as in case of special integral we have the quadratic polynomial. You have to make a perfect square, and we have done at least 2 lectures based on the integration by making the perfect square. What you have to do it again, I'm explaining it again. To make it a perfect square, first of all the square of the coefficient of x square should be equal to 1, which is 1 here itself, and you have to add the square of half of the coefficient of x, which is 4 here, and half of it will be 2. So adding and subtracting 2 square, adding and subtracting, so it will be a whole square of x plus 2, and it is minus 4 plus 6, it is 2, so it is root 2 whole square, and this is a special integral of under root x square plus a square, which is equal to x by 2 under root x square plus a square upon 2 log x plus under root x square plus a square. In place of x we have x plus 2, in place of a we have root 2. Arrange, open the bracket of the whole square here also, and this also will get x square plus 4x plus 6. Again same thing is there, you have to make a perfect square. Again the coefficient of x square is 1 itself, so you have to adding and subtracting this half of this square of this 4, which is 2, adding and subtracting 2 square, so it is x plus 2 whole square, and minus 4 plus 1 is 3, and it is root 3 whole square. There is a special integral of under root x square minus a square, that is x by 2 under root x square minus a square minus a square upon 2 log x plus under root x square plus a square. In place of x we have x plus 2, and in place of a we have root 3. Again in this it is a quadratic polynomial. You have to make the coefficient making a perfect square. Here the coefficient of x square is not 1, so you have to take minus 1 common in it, making a perfect square by adding and subtracting half of 4, which is 2, adding and subtracting the square of 2, this it will be x plus 2 ka whole square minus 4 minus 1, it is 5, and it is root 5 whole square. Arrange this minus sign, this will be positive, this will be negative, and it is special integral of under root a square minus x square, which is x by 2 under root a square minus x square plus a square upon 2 sine inverse x upon a. In place of x we have x plus 2, and in place of a we have root 3. So these are special integrals of making it by integrating by the perfect square. Again the same thing is there, x square plus 4x plus 5, the coefficient of x square is already 1, so you have to subtract squaring and adding the half of this coefficient of 4x, which is 4, that is 2 square minus 2 square, this become x plus 2 whole square, and it is 4 minus 5, it is 9, so it is 3 square, and the special integral of under root x square minus a square, which is x by 2 under root a square minus x square minus a square upon 2 log x plus under root x square minus a square. In place of x we have x plus 2, in place of a we have 3. Arrange it, simplify the square root, you will get this. Again, you have to make a perfect square, make the coefficient of x square as positive by taking minus 1 common, making the perfect square in the square bracket by adding and subtracting half of 3, which is 3 by 2 whole square, adding and subtracting. So it is x minus 3 upon 2 whole square, and this will be 9 upon 4 minus 1, so it will be 13 upon 4. Arranging this minus sign, this will be positive and this will be negative. If you remove this negative sign in the square bracket, so it is root 13 upon 2 ka whole square, and this is x minus 3 upon 2 ka whole square. That is a special integral of under root a square minus x square, which is x by 2 under root a square minus x square plus a square upon 2 sine inverse x upon a. In place of x we have x minus 3 by 2. In place of a we have root 13 upon 2, and arrange it. Simplify this bracket, simplify this square root, you will get this. Again, this is x square plus 3x. It is a quadratic polynomial. You have to make a perfect square. The half of 3 is 3 by 2. So adding and subtracting 3 by 2, it will become x plus 3 by 2 whole square minus 3 by 2 whole square. It will become a special integral of under root x square minus a square, which is x by 2 under root a square x square minus a square upon 2 log x plus under root x square minus a square. In place of x we have x plus 3 by 2. In place of a we have 3 upon 2. This, see the bracket, square and subtract, you will get in the square root x square plus 3x. Again, this is 2x plus 3 upon 2. Simplify the square root, it will be x square plus 3x. And it is a simple under root a square plus x square. First of all, take 1 upon 9 common in it. It will be 1 upon 3 outside the square root, and there will be 9, and in place of 9 it will be 3 square. You know how to arrange it. And a special integral of under root a square plus x square, which is x by 2 under root a square plus x square plus a square upon 2 log x plus under root x square plus a square. So all these questions based on a special integral of this exercise 7.7. Question number 10 is direct question, which is under root 1 plus x square, which is x by 2 under root a square plus x square plus a square upon 2 log x plus under root a square plus x square. Under root integral of under root x square minus 8x plus 7, make a perfect square by adding and subtracting the half of 8, which is 4. So adding and subtracting 4 square, it will be x minus 4 ka whole square, and minus 16 plus 7 will be minus 9, and that is minus 3 square. So it has special integral of under root x square minus a square, which is x by 2 under root a square minus x square plus a square upon 2 log x plus under root x square minus a square. In place of x we have x minus 4. In place of a we have 3. We can simplify this square root. If you open this bracket, you will get x square minus 8x plus 7. Similarly here. Now from 12 onward, that is 12, 13 and 14, we have a type of question linear quadratic, as we have done in the fourth exercise in the special integral. You have to try to make here the derivative of this x square plus x. So what is the derivative of x square plus x? It is 2x. So I have to bring it here 2x. So how can I bring it? By multiplying divide by 2. So if you let x square plus we need also 1, because the derivative of x square plus x is 1. 2x plus 1, so I have to bring 2x plus 1 here. So first of all I brought this 2x, and then adding 1 and subtracting 1, I have got 2x plus 1. Why? Because the derivative of x square plus x is 2x plus 1. So now you can break into two integral. Half 2x plus 1 into under root x square plus x, and minus half into under root x square plus x. See it very carefully. Now see it very carefully. If you let it x square plus x is equal to t, this will be cancelled out. If you let this equal to t, when you put the value of dx, here, you will get under root t with respect to t, because this 2x plus 1 will be cancelled out when you put the value of dx. This is dx. So it is root t, and you know the integration of this. We have to make it the integral by making a perfect square. The coefficient of x is 1 and the half of it is 1 upon 2, adding and subtracting 1 upon 2 whole square. So it is the whole square of x plus half, and this is minus half ka whole square. This is special integral of under root x square minus a square, which is x by 2 under root a square minus minus a square upon 2 log x plus under root x square minus x square minus a square. In place of x we have x plus half, in place of a we have half. Arrange the square root taking care of all the terms, 2x plus 1 upon 4, and if you find the whole square it will be x square plus x, and similarly here. And this integral root x, you can know it, t की power half plus 1 upon half plus 1, and put the value of t, which is you have let it equal to x square plus x. So this is a linear quadratic type question which I have already done in the previous exercise also. Similarly, in question number 13, we have this x plus 1 under root 2x plus 3. Now you have to obtain the derivative of 2x square plus 3 here, whose derivative is 4x. So how can you obtain 4x? Multiply and divide by 4. So it is 4x plus 4, and it is a 4x the derivative of this. So separate into 2 integral 1 upon 4, 4x into this, 1 upon 4 into 4 into this. See it? Open the bracket, this into this into this in the one integral, 1 upon 4 into 4 this in the other. Now if you let 2x square plus 3 is equal to 2, this 4x will be cancelled out. When we put dx, the value of dx, dt upon dx, this will be cancelled out, so it will be root t, and this can be a special integral. When you take 2 common in it, it will be x square 3 upon 2. When you take 2 outside the square root, it will be root 2. So it is x square plus root 3 upon root 2 ka whole square, which is a special integral of under root x square plus a square, which is x by 2 under root x square plus a square upon 2 log x plus under root x square plus a square. In place of x we have x as it is, in place of a we have root 3 by 2. You can arrange these three terms to simplify as far as possible. Similarly, is the last question of this exercise, which is 14, that is x plus 3 in under root 3 minus 4x minus x square. You have to obtain the derivative here of this, which is minus 2x minus 4. I need minus 4x minus 2 here, the derivative of this, minus 2x minus 4. So how you can obtain minus 2x? Multiply and divide by minus 2. So it will be minus 2x minus 6, and I need minus 4 also. So minus 4 minus 2, you can either add and subtract minus 4, or you can break minus 6 as minus 4 minus 2. Now separate into 2 integral, this into this and this into this, taking care of this half, minus half. So minus half in this into this, and plus 1 integral of this. Now when you let this is equal to t, naturally this will be cancelled out. It will be only root t with respect to t when we put the value of dx from this, and is a special integral which can be obtained by making a perfect square by taking minus common, adding and subtracting half of 4, which is 2 square minus 2 square. It will become x plus 2 ka whole square, and minus 4 minus 3 is 7, which is a whole square of root 7. So taking care of this negative sign, this will be positive and this will be negative, and it will be a special integral of under root a square minus x square, and you can integrate this root t, which is t की power half plus 1 upon half plus 1 for the value of t, which is 3 minus 4x minus x square. And the special integral of under root a square minus x square, where a is root 7 and x is x plus 2. Arranging the terms in the last two steps and simplify as far as possible. So this is the completion of the exercise 7.7, and we'll discuss in the next lecture. Thank you.